In this segment, Captain Orion discusses flight in and outside Earth's atmosphere and the problems caused by friction and heat. How is the great amount of heat dissipated? Why is being creative important to our future scientists and engineers?
Oh, here's our beautiful planet Earth. Within our beautiful planet Earth, we have the atmosphere, right? The atmosphere that surrounds our planet. Within that atmosphere, we have millions and billions and trillions of air molecules that we can react against to make this work. So what do we do? Yeah, so what do we do? What do we do when we go beyond, right? Beyond that atmosphere. We're not going to have air molecules out there anymore that we're going to be able to play with. Yes, our beautiful planet Earth. Oh, oh, yes, oh. Ah, yeah. So we're going to go ahead and demonstrate how that's going to work. Oh, we're going to actually go ahead and launch a space shuttle. Space shuttle, you know, it can go ahead and react against all that air molecule while it's within the atmosphere. But then it's got to go beyond the atmosphere and go into outer space. So my space shuttle, we're going to go ahead and launch the space shuttle. This space shuttle is going to fly around this room, and it's going to come back and land in my hand. What do you think? Yeah? Shall we do that now? Yeah, cool. I have this very special propellant that I have that we're going to be able to go ahead and do that with. Okay, you guys ready? Okay, here we go. Oh, but you know what? Last time that we launched a space shuttle, we put a Japanese satellite into outer space. So we have to do the countdown in Japanese. Do you guys know how to count in Japanese? Yeah, some of you do and some of you don't. Well, you know what? Because Lockheed Martin, you know, we have what? We have thousands and thousands of employees. We have to come up with a way of being able to teach them how to count in Japanese as well. So we came up with a very special method, and it's called Learning Japanese in Accordance with Justin Bieber. Yeah. And we did that because we know that everybody loves Justin. Yes. Oh my gosh, everyone loves Justin. Yes. So, Justin, right? Justin's mother says, okay, Justin, you know, you made so much money for the family that we're going to go ahead and take you and your sister to Japan with me. Yes, she has a sister. Pretend. So Justin and Justin's sister, right, is in Japan. And the first thing that happens to Justin, well, it's a lot like here. Well, in Japan, well, Justin gets bit. Oh, and he gets bit by a mosquito. Yeah. And he gets bit by a mosquito. Yeah. Oh, man. So Justin gets bit in the mosquito, but Justin gets bit in the knee by a mosquito. So what kind of knee does Justin have? He has a what? Oh my gosh, yes. He has an itchy knee. And you know what you just did? You just learned how to count 1, 2 in Japanese. Ichi ni is 1, 2 in Japanese. Oh my gosh, you guys are so smart. You guys must be students at Manatee Elementary, aren't you? Yeah. So ichi ni is 1, 2 in Japanese. So Justin's mother says, okay, Justin, you have an itchy knee. And Justin, because you are my son, I want you to take your sister, who is a she, and go to the bathroom. You know what you just did? You just learned how to count 1 through 5 in Japanese. Oh my gosh. It's ichi, ni, san, shi, go. That's 1 through 5 in Japanese. Is that so cool? Oh my gosh. Yeah. Should I just take the next 10 minutes and teach you the entire Japanese language? Yeah. Okay. Maybe we can do that in a little bit. Okay. So we're going to go ahead and do the countdown in Japanese. We're going to launch the space shuttle, but we're going to go ahead and practice. Okay. Everyone, we have a loud ichi, ni, san, shi, go. 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 Wow, cool. Okay, we're going to do that, and we're going to launch Space Shuttle. Ah, cool, Space Shuttle. It's going to be so cool. Okay, ready. You know, you guys are going to have to really keep a really close eye on this because it's going to happen really, really fast, okay? Okay, here we go. Ichi, ni, san, shi, ga. Whoa, did you see that? Oh my God, did you blink? It flew around the room and came back and landed in my hand. Did you see it? Hi, did you all see that? Yeah, you guys all saw it. Oh, you want to see it again? No, we only do it once. So what happens? Well, the space shuttle is now in outer space, right? It's in outer space, and it's in what we call an orbit. Orbit, right? It's all going around and around, and it's pointing down so the astronauts can see down there at our beautiful planet Earth. And then what happens? Oh, a really cool thing happens because now we can bring things up there, right? Like that's how we put the International Space Station, how we went ahead and assembled that in orbit. The space shuttle, yeah, it has this big old cargo compartment door, and it opens up. Big old mechanical arm comes out, and it takes that payload right out of the payload compartment, boom, pulls it right out, and gently puts it into orbit. Yeah, now we can go ahead and put whatever we put out there, like different parts of the International Space Station, so we can go ahead and continue to assemble that out in outer space. But now what happens? Well, we do have astronauts on board the space shuttle, right? Astronauts over there, well, yeah, astronauts are human beings. They have family, they have wives and husbands here on Earth, so we need to be able to get that space shuttle back here on Earth safely. That space shuttle, yes. So pretty soon, we have to get it out of orbit, and then we have to re-enter the atmosphere to be able to get that space shuttle through the atmosphere so it can go ahead and land on Earth. Well, you know, remember we said that the atmosphere surrounds our beautiful planet Earth? Well, and within that atmosphere is all that air molecule. We know that we can't see air molecule because it's too small, but we know it's real, right? Because you can feel it. Well, all of a sudden, as the space shuttle comes in and it starts to re-enter the atmosphere, well, the bottom of the space shuttle, right, it starts to get really red hot. And that's because, why? It's kind of like when you take your two hands and you rub them up against one another. Why does it get warm? Yeah, that's all it is. It's just friction. So the space shuttle, as it comes in at supersonic speeds, you know, it re-enters the atmosphere. Well, the bottom gets real hot just because of friction. And if we don't get rid of all that heat, bad things can happen because all that heat, it can go ahead and enter the wing structure, right, of the space shuttle, and the wings could fall off. And we've already had that happen once over the state of Texas. That's how we lost one of our space shuttle and all the astronauts on board. So to be able to go ahead and take all that heat and to dissipate all that heat is going to be very important. Space shuttle, bottom of it is lined with hundreds of these space shuttle tiles. Space shuttle tile is very cool in that it can go ahead and take all that heat and it can go ahead and get rid of all that heat. I'm going to go ahead and demonstrate to you by using my very favorite way of demonstrating these. Oh, and we're going to have Janet be our safety standby with our fire extinguisher. So you kind of know what I'm going to be doing, huh? Oh, yes. Poof! Oh, fire! Yeah! So, space shuttle tile, you guys have probably seen this on TV. As the space shuttle or any space exploration vehicle re-enters the atmosphere, yeah, it kind of looks like this, the bottom of the space shuttle. Yeah, a lot of heat that's being applied against that space shuttle. Well, the space shuttle tile is very unique in that it can go ahead and take all that heat and it can go ahead and dissipate that heat. Dissipate meaning take all that heat and get rid of it, not absorb it. So the space shuttle tile, what would happen to if the space shuttle tile was made out of wood? Yeah, it would just burn right up, huh? How about if it was metal? Yeah, it would just melt. Because metal would just absorb all that heat and it would get hotter and hotter and hotter and pretty soon it would just melt right off. In fact, if this was made out of metal, I wouldn't be able to hang on to that space shuttle tile because it would absorb that heat and it would be way too hot for me to hang on to it like this. That heat source is real close to my finger and I can't even feel that heat. In fact, I'm going to go ahead and turn this gas off, and then I'm going to show you just how good it is at being able to dissipate that heat, because I'm going to go ahead and put this space shuttle tile up against the volunteer's face and see if it's going to burn their face. Oh, cool, we have lots of volunteers. Yeah, because you can see that it's red hot right now, huh? Okay. Oh, we have lots of volunteers. Oh, but you know what? Last time I did this, I actually burned a volunteer's face, and I got into a lot of trouble. So I'm going to go ahead and put it up against my face. Oh, do you think it's going to burn my face? Yeah? You think so? Yeah? Well, some of you do, and some of you don't, and some of you hope it does. So we're going to go ahead and try it. You guys ready? Let's try it out. Okay, ready? Ah! No, it's not hot at all. It's just a little bit warm. You want to feel it? You want to feel it? Yeah, see? You want to feel it? Yeah. Yeah. Yeah, it's just a little bit, huh? Yeah, so it's not hot at all now. Yeah. Good thing about Space Shuttle tile, it's very, very light, because for every pound that we take into outer space, it gets to be very, very expensive. It costs thousands and thousands of dollars. So everything that we put into a space shuttle, we have to really be thinking about weight, how to make it lighter. Oh, this is really, really light. Huh, we can go ahead and take the silicone, and then we can take that silicone compound, and we can just go ahead and put a lot of pressure onto it, and then we can go ahead and make the space shuttle tile. Bad thing about it, though, is the space shuttle tile is kind of fragile. That's why that every time that we put a space shuttle into outer space, yeah, there's going to be some damage to that space shuttle tile just from the ice falling on it. So when we get into outer space, we want to make sure that we look at the space shuttle tile and make sure that it's going to be safe to be able to bring that space shuttle back in through the orbit, through all that heat that it generates on reentry, and be able to land that space shuttle. That's where, that's part of the reason why I'm here, because we need a lot of young people who's used to thinking outside the box, to be able to come up with a replacement for things like this to help us get further and further into outer space, right? One of the cool things that I got to do working for Lockheed Martin is to go on a lot of these zero-G gravity flights. I've been 6 of those. So what we'll do is this. We'll get on board a Boeing 727. We'll start at about 24,000 feet, and we'll do a zoom up maneuver, right? And as we reach about 34,000 feet, we'll do a push-down maneuver. As we push down on that Boeing 727 and we start going down, well, we can maintain about 30 seconds of zero-G gravity conditions. Right? So about 30 seconds, we can do all kinds of experiments to be able to simulate what that astronaut is going to be seeing in outer space. Simple things that we didn't think about. Well, how do you drink water, right, in that zero-G gravity condition? Because if you had a bottle like this and then you try to drink out of it, as soon as your lip comes away from that bottle, well, all this water is going to come out and it's going to be just big globs of water just floating around. Have you guys seen on TV where these big globs are out and the astronauts, all they do is they kind of go like this and then get that water? That's kind of cool if you only have 1 or 2 droplets, but if the cabin is full of these big gobs of water, that's not good. Other things, well, simple things like, eating food or going to the bathroom. Oh, how do you go to the bathroom in zero-G gravity conditions? Oh, right? Because as soon as you're on that potty, and then you're going to have a hard time staying on that potty, because you'll tend to just float right off the potty. Yeah, so what do you have? Seatbelts. Yeah, when you go to the potty, you have seatbelts, so you just strap that seatbelt on, just like you do in your car. You want to keep yourself on that potty. And then what do? Well, we keep pressure differentials again. Oh my gosh, we talk about pressure differential all the time, right? Because when we go potty, we have to make sure that we maintain negative pressure, right, underneath you. So anything that comes out, well, it just gets sucked right out, and it doesn't go floating around. Because it's going to be very important that you don't have, any kind of anything like that floating around inside the cabin of the space shuttle.